Alright, let's figure out how to do domains of compositions. And the way we're going to do this is to start with, I don't know, kind of a story, I guess. So we have two factories, a factory G and a factory F. And what's going to happen is that factory G is going to make stuff and send it to factory F, and then factory F is going to make stuff out of that. So what we want to do is figure out all the things factory G can use to turn into things that factory F can use. So here are the resources that we have for factory G. So it has the option of using any of these. So you got green, purple, blue, orange, and gray, I don't know, little circly things. So what's going to happen is you look at all these resources and you start deciding like which ones you can use. So green can be used. And when you take green and you put it into factory G, it's going to create some resources for factory F to potentially use. And in this case, it makes, I don't know, green diamonds. And let's keep going. So let's say you can use the blue ones, and the blue ones are going to create some blue diamonds for you. And then the purple ones, and they create purple diamonds. And the orange ones, which will create orange. But then let's say we're done. So you look at all the potential resources, and it turns out there's one that you can't use. So what we'll do is look at that and just get rid of it. So that's actually out. It's no longer an option for us. Alright, so now what we do is we move on and we look at the things that factory G created that factory F could potentially use. And we do the same thing. So let's start with the green diamond type things. So those can be used, and it's going to make a, I don't know, green hexagon. Doesn't really matter what it makes at this point. What else can we use? Well, the purple ones work, and they'll create a purple hexagon for you. And the orange ones work to get an orange hexagon, but let's say we're done there. Okay, so you actually cannot use these blue diamonds. Now, since factory G is responsible just for making things that factory F can use, if factory F can't use the blue diamonds, then there's no reason for factory G ever to use the blue circle things. So what happens is we get rid of those, which means going back to the entire option list of resources for factory G, we want to get rid of those blue ones because they're never going to get used. So what ends up happening is, for this whole system to work really well, factory G should only ever be using the green, purple, and orange, which will end up working its way through factory G to become the diamonds, and then the diamonds become the hexagons. But anyway, that's kind of a little story, because what we really just did was try to find the domain of a composition. So it's the domain of f of g of x. So that's what we just did. So let's see if we can understand how to do that. So the domain of a composition f of g of x, which sometimes is written with g of x actually shown inside f of x, and other times you get that fog notation. So first step is that you want to find the domain of g. And the domain of g is going to be the absolute biggest possible domain for the composition. So it's possible that there will be no additional restrictions. Maybe that'll just be the domain of the composition, but sometimes there are additional. So what we had was we got some green, blue, purple, and orange, and we got rid of the gray one. So the gray one didn't work. So that's our biggest possible domain there, is those four types. The next thing we did is we figure out the domain of f, and then we want to make sure that we recognize what's not in the domain. That's actually the really important part there, is figuring out what's not in the domain, because we're going to have to do something with that. So for us, we had these green diamonds, we had purple, we had orange, and then we had this one problem one. So blue was out. And since blue was out, we need to go and figure out what created that blue diamond. So we figure out what creates the blue diamond, or whatever's not in the domain of f, and we want to eliminate it, right? So what we're trying to do is get rid of anything that created a blue diamond for us. So what created it? Well, that blue circle thing there. So our final ultimate domain that we ended up with for the whole composition was just the green, just the purple, and just the orange. So we lost blue kind of in the final step. We lost gray right away because it wasn't in the domain of f. So that's how it works. Let's do an example using functions, which you might prefer. Okay, so we're going to find the domain of f of g of x, where g of x is 1 over the quantity x plus 1, x minus 2, and f of x is 1 over 4x minus 1. So the first step is we need to find the domain of g of x. So that you can find just by looking. You can't divide by 0, so you got to kick out anything that would make you do that. So the biggest possible domain for our composition is real numbers that are not equal to negative 1 and 2. Now we're going to find the domain of f of x. So for the domain of f of x, we can also do that by just kind of looking. So it's going to be all real numbers that are not 1/4, because again, you can't divide by 0. Okay, so now comes the part where we need to eliminate anything from the domain of g of x that generates a 1/4, because we can't use a 1/4. So the way we do that is we really just solve g of x equals 1/4. Which is going to give us this. And then I'm going to expand and take reciprocals at the same time, just to speed it up. Move that 4 over, and factor. And then set it equal to 0 and solve, so x is 3 and x is negative 2. Now those are not going to be in the domain. Okay, so our final answer looks like this. So the domain of the composition, f of g of x, is x is an element of the reals, x can't be negative 1 or 2, and that comes from g of x, and x can't be negative 2 or 3, and that comes from removing things from the domain of g of x that generate values that aren't in the domain of f of x. So we had to get rid of anything from g of x that would have created a 1/4, and that's what we did. I hope you found this helpful, and good luck.